Welcome everyone to the Wednesday webinar by PDSVISION. My name is Michael Wimberly and we will be discussing mechanism design using Creo today. The overall agenda is, of course, to go through and review the mechanism design functionality. So I'll go through a brief introduction of myself and PDSVISION, a brief overview of mechanism design, and of course, the main thing is the actual live demo. And then we'll have a Q&A after it. If you have any questions, there is a questions area in the webinar interface. You can go in and type in your questions in there. I'll probably address most of those towards the end of the webinar, but definitely type them in as you have questions as we move forward. All right, so once again, my name is Michael Wimberly. I'm the Technical Director in the Customer Success area of PDSVISION. I've been with PDSVISION over 11 years now. I've worked with PTC products for over 25 years, actually coming up closer to 30 now. And I've been in the PTC channel for over 20 years as well, being a certified trainer as well as an implementer of Creo and Windchill. PDSVISION at a glance. Once again, our headquarters is in Stockholm, and we have operations in 12 countries. We are a trusted advisor of software solutions and services in the digital transformation with over 2,500 years, of course, combined of technical experience. We are one of PTC's top partners worldwide, and of course, rapidly growing partner of ANSYS as well. We also have My PDS apps that we can also go through and use, and there's actually webinars that we've had on some of those as well that we can also go through and use that correlate with different PTC products, whether we're talking Creo or Windchill. All right. And then, of course, the digital transformation journey. Just overall for companies, this is the areas that people are growing in as technology grows and grows and grows. The way we do things also is changing as well. So with products, basically we're looking at making products smarter, connect them with the Internet of Things, IoT, and of course fulfill regulations, and of course build the digital twin. So we do have the physical part, but we also want a digital equivalent of that is as functional as the physical one is. Of course, for production, we always want to decrease manufacturing downtime. We want to be able to go in and predict failures, which once again, that gets into some of our quality type tools. With the aging workforce, we want to be able to capture that knowledge and that experience, and we can do that by actually using some technology to streamline some of the functions that were done in the past, and of course, optimize production through AI, the artificial intelligence. For processing, remove data silos. Instead of just having data in one location, that's the only place it is, and it doesn't share with anything else. We're removing that. That's where Windchill really comes into effect, because now we can store everything in Windchill, and then everything can point to Windchill. So we do have one set of data. We don't have multiple copies all over the place, and everybody's always looking at the same information. And of course, controlling who can do it, who can access that data as well. Smart connected systems, and of course, smart connected operations, and of course, service and operations. So once we get into Windchill, you also get into manufacturing with manufacturing bombs. You got service bombs to be able to go in and build out some of that as well. The infrastructure, reduce non-value IT costs. Overhead. Everybody's looking to cut overhead. So when we talk about non-value stuff that doesn't benefit us. And of course, everybody's looking at cloud and SaaS, software as a service. That's moving forward as well, even within the PTC products. Once we get into or start dealing with Creo Plus and Windchill Plus. And of course, data as well, big data, create a value out of data, AI, data lakes, analysis, as well as data and cybersecurity, and of course, create new business models. So once again, as technology advances, the way we do things also will be advancing as well. One of the things that we had talked about in the past, and if you guys have watched any of the webinars that we've had in the past, or last year and the first part of this year, we did a whole thing on digital thread and how all the different areas can connect. So right now we're looking at the product visualization, or virtualization piece of it, of course, the direct CAD, but you can see there's also process virtualization, digital manufacturing, and connected products as well. So all those things, make up the whole digital thread. And as I said, what we're dealing with for this one is directly in the product virtualization with the CAD functionality itself. All right, so real quickly, like I said, very, very brief overview of dealing with mechanism design. There are two methods of assembling components into an assembly. You have constraints, which is your, just two surfaces meeting up with each other. You have the coincidence of axes, so that nothing actually moves. Everything that you're going to assemble is static, has no movement whatsoever. And then we also have connections. Connections, movement is allowed. It is controlled by the connection type. So we have pin connections, cylinder connections, we have ball joints, we have gear connections, we have all kinds of things that we can go through and build up. But once again, the way they move is controlled by the type of connection that we're using to still lock it in certain degrees. So it's going to have a degree of freedom, but we don't want it to have a full degree of freedom. And then when you get into the mechanism tool, it actually uses the connections and some of the additional tools within the mechanism environment itself to allow for realistic movement and control of your file. So we are going to deal with connections, and then there are a few things that we're going to do in mechanism as well. Mechanism is a big environment, and there's a lot of functionality inside of it. And what we'll do next year is actually dig deeper into a lot of the mechanism tools, whether we're just talking things for movement, like assigning motors. You can even, there's the ability, of course, to check for interferences, but then there's also mechanism for analysis that you can also do as well. So we'll go into those a little bit more in 2024. For this one, we're just going to kind of focus on, some of the connections and some of the tools inside of mechanism itself. And of course, when you are using your assemblies, they can have a combination of constraints, things that don't move, and connections, things that do move. All right, so we will go ahead and jump into the demonstration. Make sure there's nothing else. All right, so the first thing we're going to look at is an enclosure. So we have this box here. Once again, it could be your computer where we're going to put our servers and things like that, or it could be for an electrical cabinet, whatever it may be. So we have the cabinet already designed. We just want to go through it now, put the door on. You can see that we have the part of the hinge here, and of course the secondary piece of it will be on the actual door itself. So we'll go ahead and assemble that in. Nothing here is different. Brings it in. And inside of here, once again, we have our 3D dragger. We can just simply go in and stand it up. We can use it to move it around. Sorry, center everything. Apologize. And then for this, I am going to assemble this part of the hinge to this part of the cabinet. So with that, we can go in and use our regular constraints, but for this specifically, I'm going to use a pin connection. Now with the pin connection, what you're doing is you're going to line up an axis or cylindrical surfaces that it's going to rotate around. And then we're also going to go in and lock in a translational reference so it doesn't move up or down or back and forth along the axis, but it only rotates around the axis. So what we're going to do is I'm going to use this cylindrical surface here, and I'm going to assemble it to this cylindrical surface here. Now, as you can see, it immediately snaps into position just like it does when you're using regular constraints. And now you can see that my 3D dragger has now limited the amount of movement that is possible. I can move it up and down, and I can rotate it. But for what we're doing, the only thing we wanted to do The only thing that we wanted to do is be able to rotate. We don't want to move it up and down. So if I come over here and I zoom in here, for my translational reference, I'm going to say associate this surface here with the undersurface here. And that goes in and locks that in. And there we have it. So now you can see we've locked out that other degree of freedom, and now the only thing it can do is now rotate around the axis. Great. Now it's there. So inside of our model tab under drag components, we can just pick it and move it around. But if you notice, I can move it all the way around. There are no limitations right now as to where this will start and stop. So we want to go through and add that as well. So what I'll do is I'll go back into this door again, come back over here to my connections, and there's this other option here for rotation axis. What we're going to go in now and do is give it, although it says rotation axes, we're actually giving it two planar surfaces to basically determine a 0 degree angle. So it's still going to rotate around the axes, but we're now going to go in and say for this surface and this surface, we're going to go through and define that as 0. Sorry. So I can define that as my 0 angle. But if you also notice, right now when I move it, it now makes that angle a negative value. So it's saying that my angle is negative. So between those two references, it's saying that's a negative direction. That's very simple. All we're going to do here is pick on the actual connection, right click on it, and there's a flip connection. And now what that does, it changes it from a negative to a positive. So now coming in this direction is our positive angle. Very simple. So this is just simply showing where the position is now. Great. Now, what we want to do once again is limit the angle. So we're going to come over here and say that the minimum angle, we don't want it to be minus 180. We just want it to be 0. And then the maximum angle we want it to be is 180 degrees. So it can open up flat. That's it. Great. Completed. Now, same thing. When I take my drag components, select on it, move it, it only goes that far, 180, and it will only close. It won't go past 0. So I've locked that in. Awesome. Now, there is one other thing that we can do with this. We can actually go in and specify that every time this model gets regenerated, we always want the cabinet to be closed. Right now, if we regenerate it, it just simply stays where it is. It doesn't go in and update anything. But whenever we regenerate, we want it to always go to the quote unquote home position. So inside of here, we have this item over here for regen value. Right now, we're saying that the regen value is going to be 0. What we simply need to do is select this checkbox to say enable it. Great. Once again, checkbox, and you can see that it automatically closes. So when I drag it, great. Then once I'm done and I just regenerate my model and I'm just using Control G, it automatically closes. So you can also set that up so that no matter what, although you may be manipulating it to look at it, it will always go to the home position, for lack of a better way to say it. So we can go through and lock that in as well. If you don't want it, then of course it's just a matter of unchecking this box. And now we can drag it, leave the door open, and get yelled at by your parents because you left the door open. All right, so that is a pin connection. So I showed you a few other functionalities inside of it, but once again, a pin connection is lining things up cylindrically, whether you're using the actual axes or cylindrical surface, and you're going to go in and lock it down so it doesn't translate along that axis. It just rotates. And then once again, additional constraints to go in and limit the actual angle that is actually opening or closing it. All right, so that is the first one. Next is the gear assembly. All right, so with this, we have two gear assemblies associated here. They're assembled. Now, with this, remember I talked about assembling in static components. These are actually assembled in static. But if you open up one of those assemblies, the actual rotation of that is in the subassembly and not in the top level assembly. So this assembly is assembled into the top level assembly as a static or a regular constraint, but it has mechanism or connections inside of it. Now, right now, this one moves and this one moves, but not with respect to each other. So what we want to do is we want to go through and now create a gear connection between those two so that they move together. So to do that, we're going to go into the application, and then we're going to go right into mechanism. Now, when you are going in and doing a gear connection, it is simply a type of connection. It doesn't mean that the component that you're using has to be gears. It can be rollers, because what we're going in and dictating, or sorry, is showing is the rotation of two components or two or three components with respect to each other. So I'm going to go ahead and do a gear connection, and you have gear 1 and gear 2 that we're going to go through and specify. Once again, these both are in here using a pin connection, so they rotate but don't translate. So I want to use this connection here as the first one, and then what I'm defining is the pitch diameter. So we know with the pitch diameter is big gear, little gear. Big gear turns slow, little gear turns fast. That's the ratio that we're creating between the two. So this diameter, I'm going to go in and make this one 140 diameter pitch. And then I'm going to go into gear 2, select this one. And then for this pitch, I'm going to go through and make it 95. That's it. So we've now gone through and associated this connection with that connection, and now they're going to rotate with respect to each other. And you can see now, you will see this connection between those two. And if I go in and drag the component, you can see that they both move. Now, what we don't necessarily see, and that's just because of the way it's created, is these are actually moving as well. So a simple way to visually see that is I'm going to go in and take this component. I'm going to go ahead and just activate it in the assembly. I can open it up, but I'm going to activate it where it's just that part that's active. I'm going to go ahead and throw a hole in this surface real quick. And I'm going to associate it with the side of that, and then expand it here, control key with the top, and that now gives me a location for that. Great, and I'll go ahead and make it through all. So this hole that I am now creating will go through both sides of the part. You can see that over here as well. It's not intersecting in the middle. It's only intersecting the part because I made the part active. Now, the benefit of that is this part is used on both assemblies. So that hole also is here. So now when I go through and I rotate this, I can also see that geometry moving as well. And once again, it's just more of a visualization. I wouldn't put a hole in it because it would basically mess up the integrity of the model. But just so visualization, you can see that yes, all of this is turning at the same time, and they are turning with respect to each other. So that's why I also say, and this is kind of a good example, this over here shows the gears rotating with respect to each other. Now, if we had some type of a roller assembly, this is the example of that here. The rollers rotating with respect to each other. And the same thing, the diameter of one roller with respect to the diameter of the other roller will be your pitch diameters. So, all right, so there is your gear connection, once again, and some of the ways of going in and manipulating that as well. All right, now for this one, this is a slider connection. So it's a little bit similar to the pin connection, but kind of the inverse. So it's the same, but different. So I'm gonna go ahead and assemble in, excuse me, first part, which is just this rail. And I'm going to go ahead and use the default constraint. So that it's just right there. And then I'm gonna go in and assemble in the truck on this rail. So assemble, here's this one. Now, with this, once again, I'm not using a static constraint. I am using a connection, and this one is going to be a slider. So once again, with the pin connection, it rotates around the axis. With the slider connection, it's going to translate, basically move up and down along the axis. So I'm going to go ahead and select on that. Now for this one, it is looking for an axis to do so. Now, because we are dealing with two basically non-cylindrical parts, we have gone in and created axes for those to be located. I'm going to go ahead and turn off this 3D dragger just so we can see it a little bit better. So we're going to line up this axis with this axis here. And once again, we can see that it immediately goes through and aligns up the axes. Excuse me. And now for the rotational reference, because right now, as we can see, it does translate, which is what we want, but currently it does this. And we all know that's not a good thing. So we want to go through and lock out that rotation reference of this function. So for that, I'm going to go ahead and turn on my data planes. And I'm going to line up the data I'm going through the middle here with the data I'm going through. Now, once again, you look at my 3D dragger. Now I just have the ability to go through and move it this way. All right. Now, once again, turn these off. We can see that there is currently no limitation as to where this thing can go. So we do want to go through and control that as well. So there is, once again, our translation axis. Now, for those references, I'm going to go ahead and use this back surface here with the end surface of the rail. And I'm going to go ahead and just zero that out so we can see where it is. And there we have it. Now, what we want to do is we want to control the amount of travel that this has along this rail. Now, I don't know what that number is right off the top of my head. So while I'm in here, I can always go up into my analysis tool or my analysis tab, do my measurement, and find out that from here to there, it is a distance of 25.118. If I want to be that specific, I can type in that exact number, but I just want to go through and round it for these purposes. So I'll come back to my component placement. And now the maximum value that we want, I'm just going to make it 25. The minimum value is going to be 0. And then once again, once I hit and complete it, and I drag it, I can drag it forward, but it will stop at the end of that travel, and it will not go any further than that. So we can go in and lock those in as well. So as I said, a slider connection allows you to go through and translate along an axis, where once again, a pin connection gives you the ability to rotate around that axis. All right. Then we're going to go in and look at a belt connection. I'm going to come down here and filter to just the assemblies. And I want to open up the belt assembly. All right, so for this one, we're now going to go in and to my applications, and we're going to go right into mechanism to go in and define this belt. And it's pretty simple. We're going to come over mechanism, and there's belt. I want that. I need that there. I want to do it fresh. All right. So from here, once again, I'm going to go into belts. And all it's looking for right now is for you to select the surfaces that you're going to connect with the belt. So we're going to go through and pick on the different pieces of the pulleys to go through and define. So I'm going to start with this one and pick this surface here. Then holding down the control key, and what you'll notice is as I'm selecting them, they will go in and continue to populate up here in the references. Control key, I'm going to pick this one. And I'm going to come over and select on this one. I'm going to come over and select on this. Come down and select on this. There's another pulley down here that we're going to go in and select on. And then, of course, we want to come through and select on this surface. Oh, man, that worked out really well. Now, this actually looped around the way I wanted it to loop around. Depending upon the order, of course, it will go through it and twist the belt sometimes or put it on the wrong side. What you're able to do, for instance, I'm going to come down here to this number 7, and it shows you what each of the connections are or the attachments are that line up here. So if I come over here to number 7 and I select on it, I have the ability to flip where it's going. That's on this one. You can see that when I flip number 7, it's actually going from this side of this large part to the other side. Or I can come over here to number 1 and do the same thing, and you can see that it actually will create a twist because it's changing the in and out or the attachment of the part or the belt, sorry. So yeah, and that's it. Once all your pulleys and everything are in place, you go through and you define your belt. There's your belt loop, and it goes up here and shows you what the actual length of that belt is. So right now that belt, once again, unstretched, is currently almost, for rounding it, is basically 163 as far as inches. Great, complete that. Now, what does that do? Now when we come over and we begin to rotate, and we actually put a hole in this pulley just to show that, when I go through and select on this, you can see the rotation of that. And if you look at the other pulleys associated with it, I'll zoom in a little bit, we can also see them moving. So everything associated with that belt is now rotating with respect to the movement of each other. Great. Now we have it, close it, that function is there. Now, what do we do with this belt? We have it inside of our analysis, but it will be nice to have a representation of it. Okay, that's a good question. Let's go ahead and actually right click on it. And there's a pick in here that simply says, make a part. So it's going to take that loop that we just defined as the belt, and it's going to allow us to go in and make that into a part. And I'm just going to call it belt 1. Once again, using the default information, and because of where it's located, it's going to stay there. I'm just going to go ahead and say use the default constraint. So it's going to put the datum in the default constraint, and the belt is going to be basically where it is associated with all the pulleys. Great. All right. So there it is. So now when I go in to this part and I open it, there's the belt loop. Now I can just come over here and simply say create a sweep, and I want to use this entire thing. So I'm going to select that, hold down the shift key, tab until I get the whole link, and then come over and define the sketch. And I will go to my sketch view, I'll come over here, create a quick little rectangle. Make this 1, make this 0.1, just something thin. We can play with it later on. There it is. There's that geometry. Now, when I go back to my assembly, there's the belt representation. So we have that in our assembly now. All right. So there is the belt. So once again, with that one, we're going in and simply we have all of our pulleys and all of our items in the appropriate location. We just need to connect them with a belt loop. So we go through and define the actual belt using the mechanism tool. And then once we're done, if we need the representation of it, we can have it. But also remember, the benefit of this belt loop is that it actually goes in and gives us the actual length of that belt as well. So there's two statements, sorry, that are actually, one's a question and one's a statement, one's a question. When we were talking about the slider constraints, it says you are able to use datums on the fly. Yeah, definitely. Anything that we're creating, yeah, we know that when we're doing any type of assembling, whether we're talking connections or regular constraints, on the very right end of our assembly dialog box, or I'm sorry, assembly toolbar, we have the ability to go and create any datums that we need for that assembly process. So yes, we can always create them whenever we need them, whether it be an axis, whether it be a plane or anything like that to allow us to use in our geometry. And then it's asking for constraining the pulleys. Is it important that they are all exactly aligned axially? Are you saying not at an angle? So are they basically all perpendicular, like to this surface here? Or are you talking one of them that may be coming off at an angle? Is that what you're referring to? Oh, in line this way. That's a good question. I don't. You're talking this way aligned, so that they're all planar to each other. You know what? I'm not sure. I don't want to play with that here. Let me do it offline, and I'll get back with you. I'm not sure if I can have an offset pulley where they're not, once again, basically the center of the pulleys are lined up. I'm not sure, but let me double check that for you, and I'll once again alert everybody on the webinar whether or not that can actually happen. But that's not sure. Haven't done that. Yeah, you're referring to it in this direction. Okay. Yep, I'll find out and let you know. All righty. So let's close both of those, erase everything. The next one that we're going to look at is going to be a CAM connection. All right, so here is the actual CAM itself. So this is what it's going to do. So once again, using the drag, we're going to be able to go through and create the connection between the components at the lower part with the upper. So we're going to go through and actually create this type of connection. I just want to give you preview of what we're doing before I actually do it. So, all right, close that. And I am going to create a new assembly. I'm going to call it cam. Awesome. All right, so we're just going to go in and start to assemble in the components. So the first thing we're going to do, which is going to be our base component, is going to assemble in the shaft. So I'm going to assemble that shaft in. Sorry, not the shaft, the camshaft, not the regular shaft. Sorry. Assemble in the camshaft, which is here. All right, now, once again, because of this, I want this shaft to be able to rotate. So when I assemble it, and then I assemble the actual cam on top of it, I want the shaft to control the rotation of the cam. So I'm going to go ahead and once again using, actually I can show you something real quick. I'm going to still use my constraints. So I'm going to turn on my axes and my data planes. And this actually goes to one of the statements, or the statement that that Ed had made earlier about the datums on the fly. So I'm going to move this off. So right now, for my first constraint, I want to align it axially. So I'm going to take this axis and I want to align it with an axis that I have in the assembly, but I don't have one yet. So what I'm able to do is come over to the right side of my toolbar, under datums, select the drop-down menu and select axes. When I select that, if you look at the rest of my toolbar or ribbon, it's all grayed out because that is now deactivated until I finish creating my datum features. So I'm going to go ahead and create an axis that is at the intersection of this, control key, and there. So now it creates an axis at the intersection there. Great. Say OK. Now it's still paused because if I want to go in and create additional datum references, I could. So I can keep making datums until I'm finished, but I only need that one axis. So at this point, I'll go ahead and resume it. And because that is what it was looking for, it automatically went ahead and constrained it. All right, now what I want to do is I want to line it up along the axis so it only rotates but does not translate. So I'm going to come over here and do this with that. Great. Go ahead and select check mark, and there it is. Now with this, I do have, I don't know if you noticed, I've actually done regular constraints. I did not go in and create it with connections. I noticed this after I had done it. I don't want to go in and undo my constraints, but the benefit of this is that the constraints that I just used, or the references that I just used for these constraints, are the same references that I would use for a pin connection. So what I'm able to do is come up here in my dashboard and basically convert it to a pin connection. So it takes my constraints and it now makes them into pin connection constraints. So it can do that for certain items that we've gone through and created. So it can also go through and use things that is static and make it a rigid constraint. There are things we can do that allow it for slider. So we can go through in our regular connections and leave things not fully constrained and get some movement, but it's not the actual application that we want to be able to use the mechanism tools. All right, so I'll go ahead and select on that. And select OK. I'm sorry, there was another question. Is there a similar function for using a roller chains instead of a belt? I think the functionality is looping it is the same thing. I think you're just looking more at you may end up having to create a surface in the middle of the teeth to go in and define where the chain link is going to be. So instead of using the outside of that gear, you can actually go through and maybe create a surface in the middle of it that's kind of in the middle of your in the middle of the teeth that actually represents where that chain is actually going to be. So that may be something that you want to look at. All right, so coming back to this one, we did define this as an axis constraint, as a pin constraint, and it can rotate. You can see the data is moving, but one of the things that we can do just to make it easy on ourselves, I can come in real quickly, activate this part, and let's just go ahead and create a little cut on the end of it. And I'm going to go ahead and create this quick little rectangular cut right there. Great. Oh, sorry. Go back to my sketch and get rid of that line. Great. Now I am going to flip it, tell it to remove material. There we go. Once again, just a little notch in there so that when we don't have our datum planes on, we can also still see it rotate. Once again, it's just for visualization. It's not anything that we actually need for the geometry. All right, go ahead and get back to the assembly level. There's my drag, and now you can see, once again, it's moving. All right. So the next thing we want to do is go ahead and assemble in the next part, which is going to be the cam itself. And I'm going to go in, and for this one, I'm just going to use regular constraints because the movement is going to be in the shaft, not in the actual cam. So I'm going to assemble that here to here. And then once again, turn on my datums, and I'm going to line up this to there, and I'm going to make this coincident. And there we go. So now, once again, the movement is in this. So when I move that, it also moves. All right, now I'm going to put in another part. Now, normally, when we actually are using these will have some type of a platform for this example that actually is our static platform at the top as well. So the shaft will rotate, and then there is another plate or something at the above it that is static, that is actually going to be used as well. So what we're going to do is we're going to actually go in and put in a plate, but we're putting it in at a distance. So it's going to float out in space, but once again, it will represent a mounting surface or a mounting plate that we'll actually be using for this. So I'm going to go ahead and assemble in the guide. And once again, this is going to be static, so it's not going to have any movement to it. So I'm going to do that to there. And instead of doing normal, I'm going to do distance. And that distance is going to be 5. And I'm just going to line up the rest of the datums. This datum plane with that assembly datum plane. And then this datum plane with that datum plane. And all these other ones should be coincident. So that it is now just right over top of the assembly. Great. All right. Now we're going to put in 2 other parts and finish it up. So the next one, we're going to do the shaft. So for this one, we do want this once again to travel through the hole. So I'm going to go in and make this with a pin connection. So I'm going to go ahead and define that up front and define this cylindrical surface with that cylindrical surface. Pull this up. Move it up to there. And once again, I do not want it to rotate. So now for my translational references, I'm going to use that plane, and it locks it. I'm not sure what it doesn't like. Try it again. All right, so for my axial references, once again, I'm going to that out the way. Select on that reference into there. And then for my rotational reference, or, oh, sorry, wrong connection. You guys didn't correct me on that. That actually, I want to assemble that with a slider connection. I want it to slide, I don't want it to rotate. That's why it's doing what it's doing. Slider connection. Once again, this cylindrical surface to this cylindrical surface. I want it to do this. I don't want it to do this. So now my rotational reference is going to be this to that. Now it's happy because it only moves up and down. All right. And then my last item to put in here is the actual roller itself. And the same thing, I'm going to go in and use this one. This one is going to rotate about the axis, so I'm going to use the hole there. And then once again, this plane to this plane. Awesome. All right, so now I have all this in here. Now what I need to do is I need to connect this upper item, because I can go through and drag this, and you can see that it moves that. And then down here at the bottom, I can go through and rotate this, but I need them to move together. So I'm going to now come into my application and the mechanism, and it's really simple. Up here is a cam connection. So what I'm going to do is define all the surfaces of the first cam and then all the surfaces of the second. So I'm going to select on this surface, Control key, and pick all the other surfaces around it. For the first one. And then for the second one, I'm just going to go through and use this surface and that surface. Awesome. Once I select OK, there they are. Now, when I go through and drag, they will move with respect to each other. There we have it. Now, I do want to say one thing before I do the last object. When we're inside of the drag component, we have this dialog box that keeps popping up. We have this dialog box that keeps popping up. What is this for? Well, it's this thing in here that says snapshots. Snapshots are exactly what it sounds like. It is a snapshot of this configuration. So if I want to see it in different positions, I can go through and create that and then be able to jump back to those different positions as well. So as I'm going in and dragging it, and if I want to go through and lock that in, I just simply say, create a snapshot. There it is. Now, as I'm dragging it again and I get it to the top, create another snapshot. Do just the opposite. There, create a snapshot. Now, once again, with those, I can just double click on them and go back to them. And they're available to you. And if I'm not mistaken, I think you can use snapshots in drawings. I have to check that again. All right. So that's what those are for. So once again, we can always go back to those later on to see it in different positions. So once those are created, I can always come in here. And those are good. Also, when you are working in an assembly where this thing is fitting in, to make sure that it fits and doesn't interfere with things. So we can go in and use those too. All right, let's close that out. And one last thing that I want to go through and show you is this end rod. Pretty simple part. So we actually have a little ball that's going to go in there. We're kind of familiar with this, that has a hole in it that is going to rotate around. Now, to do this, we need to go in and have points to go through and control this. So if we look at this part, I turn on my axes, my datum planes, and my points, we can see that for this part, we created a point right in the middle, which is basically at the intersection of this datum plane and the axes going through the middle of that hole. So that is the center point. That's where they're going to connect with each other, and the rotation is going to be around that point. So I'm going to turn off everything but the points because that is what I'm using to assemble. So I'm going to go ahead and assemble in second part. Turn off the 3D dragger. And once again, I'm going to change this to a ball joint. I'm going to go from this point to that point. There it is. Now, once again, it's happy, but one of the things that I use old school wise is inside of here, I want this thing to rotate so I can see how it moves. If I hold down the Control and the Alt key with the middle mouse button, I can rotate that part all by itself. So I'm not using a dragger associated with it, just Control Alt and the middle mouse button will only move the part that you're assembling. If I just use the middle button, it does the whole thing. Now, I do that because what we are able to see is that this thing has full freedom while it's in here. That's not what we want. We actually want to be able to go in and control that. And as you can see, there is an option down here for cone axes. Now, for this one, instead of using planes like we have in the past, we're actually going to go through and use an actual axis. So we're going to use the axes of the component and the axis of the ball. Now, of course, it shows what the current angle is. We're going to go ahead and zero that out. Now, we also want to go through and determine how much freedom we're going to give it. And we're going to go in and say, for that, we're going to give it a freedom of 27 degrees. There's a cone. I'll flip it just so we can see it up top. But that is the degree of freedom this is going to have, is going to be 27 degrees. So once I'm out of here and I use my drag, you can see that it does not go any further than that. And that cone is what represented that angle from this axis to that axis, pivoting around the points. So it's only 27 degrees, but it has a cone area of 27 degrees. If you want to make it larger or smaller, once again, that's up to you. All right. With that, are there any additional questions on anything that was covered? Like I said, there are some things. We'll do another session that gets deeper into some of the mechanism tools, such as motors, and being able to go through and do some analysis on here as well. There's a lot inside of mechanism and the mechanism tool, so we'll go through and schedule one of those at the beginning of the year. So how would you go about creating a cylinder assembly that can be inserted into a higher level assembly? The exact same way. I would still create it. I don't know if you guys heard the question. I'm sorry. I hope I wasn't mumbling. But the question is, how would you go about creating a cylinder assembly that can be inserted into a higher level assembly? And it's once again just simply going in and creating it. Remember that gear, the gear assembly that I had, where I actually had the components in the lower level being controlled. So instead of the mechanism being here, I just created in that subassembly. So this subassembly actually has the connection in it. Now, although it's at the lower level, I was still able to go through and use those connections to tie this connection in this assembly to this connection in that assembly. So you just go through and you assemble them into that assembly, and then you use those connections to relate them to each other. So you're still creating at the lower level, you're just assembling at the top level. And once again, these assemblies were put in there static, because once again, we locked it down. But if I needed to move this as well, I could have assembled in this assembly using connections as well. So the assembly moves, and then the mechanisms inside the assembly would also move. All right, hope that one answers your question. Where is it? Next is for the slide, on top of the slide. Is there a way to control the motion of just one slide using drag? Control the motion, just one slide using. Not 100% sure on that question. I'm going to pull it back up, and if you can elaborate just a little bit more, that is Rick. If you can elaborate just a little bit more on what it is you are referring to. Oh, easy question for Rick. This is Creo 10. We're actually using Creo 10 here. So for the slide on top, are you referring to these components here, I'm assuming? Is there a way to control the motion of just one slide using the drag? Once again, I think I'm not 100% understanding the question. I apologize for that. Slide 1 goes. Slide 2. Oh, horizontal and vertical. Yes, but I would not use, I don't think what you're looking at is a cam connection. There is, let's see. Oh, hold on a second. I just need to look in here. There's different methods. What would be the best method to do that? So you're looking at moving something vertically and something else moving horizontally. I've seen that with gear connections, different types of gear connections. Don't think bearing is going to give it. Planar, no. Yeah, I know what I've seen it as, God, it's just falling off my mind at the moment. I can't remember which one it is. Let me double check that for you. I'll definitely get that to you, because I know there's a method to do it. I can't remember what the connections are, and I apologize for that. But I will get that to you. Where are we at with the question? Top line on the cam design. Will the roller stay on the cam? You drag the shaft up away from the cam. It won't, because of the way it is configured. One of the questions is, will this stay attached if this gets pulled above? And the way it's configured, it won't go above. So because of the connection between this roller here and this shaft, because of that connection, and because of the actual cam connection between this surface and this surface, this can't move off of here, which means this can't move out of that axial constraint. So it has to stay locked in that way. So I can't move this off of or higher than this connection will allow it. So there's no way to disconnect those. All right. Sure. So the question is, can you quickly go over how you got the roller to go around the cam? Sure. With that one, it was just going in into applications, into mechanism, And then down here into connections, there's the CAM connection that I created. So I will actually go through and delete that, and I will actually recreate it. So let me see if I can drop this. Now I can move it up because I removed that connection. So what I did was I came over into the CAM connection, and inside of here, I go through and define the surfaces of the first CAM and then the surfaces of the second CAM. So CAM 1, I used all of these surfaces here. So I just did the control key and picked all the surfaces around that. So what do I want this to be attached to? And then for the second CAM, sorry, there, done. Then for the second CAM, I just picked the surfaces of the rotor. So the surfaces that I wanted attached to each other along their entire rotation is what I did. And because of that, that's where it now pulls that down and locks that in. And now when I drag it, those surfaces stay attached to each other. All right. Are there any additional? I think I answered all the questions. Some of them were follow-ups to other questions, but I think I've got everybody's question. I do have a couple of them that I'm going to follow up on. So you guys will be hearing from me probably definitely before the end of the week, if not by the end of today or tomorrow. But if you have any additional questions, please let me know. Slide, access to the slide. What do you mean by, to this? What about access to the slide and as far as what? You're talking about the actual slide deck? Or are you talking connections? That's for Edward. Well, you'll actually have access to this video. So everybody that is on this webinar will actually get a link to this webinar. So you'll have that you can go back through again. So yes, you will have access to this. All right, if there are no other questions at this point, if you do have any questions that you thought about later on, please feel free to reach out to me, michael.wimberly@pdsvision.com. You can also go through and search our website for any upcoming webinars that we have. I think we have one more for the year, and then we'll start again fresh in January. And I think the one next week is for Creo Illustrate, if I'm not mistaken. So anybody that's interested in Creo Illustrate, or anyone that you know is interested in Creo Illustrate, definitely have them sign up for it. Go to our website, and you will actually see it in our events. Also visit our YouTube channel. You'll have access to any of our previous webinars. Any of the newer webinars that we've had, to access those, go to our website, and you can access those through our website. But we do have our catalog of previous webinars on our YouTube page. So once again, look us up at PDS Vision, and you'll see all that as well. So other than that, we are complete. I thank you all for your attendance in this webinar, and I hope it was beneficial to you all. And like I said, if you have any additional questions, definitely feel free to reach out, and we'll get the questions answered. Have a wonderful remainder of the day.